Hey everyone, happy Monday. Welcome to week 5 of our distance learning experience here. So what we're going to do today is kind of expand on why I went over solving systems with elimination with you guys on Thursday. So we're going to do finally part 3 of section 8.1. Okay, so first of all, hope you all had a great weekend. I'm recording this on Sunday, and I'm really excited for The Last Dance, which is the Michael Jordan documentary. If you guys are watching that, reach out to me, let me know what you guys think so far. Back to math. So here's the thing. The questions we're going to do today are a little wordy. Okay. We're going to have to kind of go through it, create a system of equations, which is 2 different equations, and we're going to solve them by using elimination. Okay. So this whole first part is a whole lot of noise. I'll read through it pretty quickly though, but the important part that we're going to look at is really what's down here. Okay. So it says Jay is moving from an apartment in Miami to one in Orlando. If Jay moves on a weekday, he will need more movers' time to pack, load, unload, and unpack because his friends will not be able to help him. But if he decides to move on a weekend, he can get his friends' help, cutting down on the number of hours he will need to hire movers. So Move Out is a moving company that supplies movers, truckers, and equipment. They have given him the following moving estimates. So if he moves on a weekday, okay, he gets 6 hours of loading and unloading, 5 hours of packing and unpacking, for a total cost of $720. But if he can move on the weekend, okay, he gets 4 hours of loading and unloading, 2 hours of packing and unpacking for a cost of $400. So just to kind of break it down for you guys, loading and unloading is basically what these movers do in terms of just getting his materials, his possessions into and out of the truck. And then they'll also pack and unpack his possessions for him as well. Okay, so that's why those are 2 different things in this case. So Move Out charges a set hourly rate for loading and unloading, and a different set of rate or a different price for packing and unpacking. So we want to determine the hourly rates. All right, a lot going on here. But again, I want you guys to focus your attention on the rates that we were given. Okay, so look at what we have for weekday. That's really important. And what we have for weekend. Okay, and that's really going to be the basis of what our equations end up being. So I'm going to slide this out of the way. And all we got to do, guys, is represent what equation can we use to represent the cost on a weekday, and what equation can we use to represent the cost on the weekend. So we have 2 different things happening here. So again, a system, we're going to use 2 different variables. So what I would want you guys to do is always tell me what your variables stand for first. You're going to define your variables. So in this case, I'm going to use X to represent the hours of loading and unloading. So I'm going to say X is going to be load, unload. Okay, and then Y is going to be pack and unpack. Okay, let me fix that Y. All right, so let's go into the weekday and let's figure out what his equation would be. All right, so it's 6 hours of loading and unloading. So if X is going to represent the rate, the hourly rate to load and unload, we're going to multiply that by 6 in our weekday situation. So therefore, we're going to start by just saying 6X, right? Because it's the price, which is X, per hour of loading and unloading times the 6 hours that we're given. Okay, we're going to add to that. Okay, so Y represents the hourly rate for packing and unpacking, and we have 5 of those hours here. So we're going to do 5Y, and that's going to be a total cost, so that's going to equal $720. Okay, and then for weekend, same idea, guys. So now we only get 4 hours of loading and unloading. So loading and unloading is represented by X. So we have 4X, okay, plus 2Y, and that's going to equal 400. So now we have our system of equations. Okay, so think back to what we did on Thursday. We want to solve this by using elimination. So that means is we want to add these 2 equations together. And when we add them together, we want one of the variables to cancel out. So either I need the coefficients on my X terms to be the same, or we need the coefficients on the Y terms to be the same. So opposites of one another. Okay. So I decided when I did mine to to eliminate my y variable. Okay, so I got to think about what's the smallest number that both 5 and 2 can multiply up to. In this case, that's 10. So to get my first equation, to get that term to be a 10, I want to multiply everything in this equation by 2. Okay, and then my bottom equation, again, since I want them to add together to cancel out, I need one to be a positive 10 and one to be a negative 10. So because of that, I'm going to multiply the bottom equation by a negative 5. Okay, so let's go ahead and multiply everything through. My top equation, so I'm going to get 2 times 6x will be 12x. 2 times 5y is 10y. And that's going to equal 720 times 2, which is 1,440. Okay, bottom equation, negative 5 times 4x will be negative 20x. Negative 5 times 2y is negative 10y. And then 400 times negative 5 would be negative 2,000. Okay. Now that we have a situation where we have these opposite coefficients for one of my terms, we're going to go ahead and add the equations together. This is where that elimination happens. So now 12x minus 20x, we're going to combine those like terms. We get negative 8x. Okay, 10y minus 10y, those are going to cancel out because 10 minus 10 is 0. And that's going to equal, on the right-hand side, 1440 minus 2,000 is negative 560. Okay, let's solve this one-step equation now by dividing both sides by negative 8. So x is going to give us negative 560 divided by negative 8 is going to be 70. So that tells us since x represented the price per loading and unloading, that means it's costing us $70 per hour to load and unload the truck. Okay, now what we're going to do is, now that we know what x is, let's take that and plug it back into one of the original equations. So I'm going to use the bottom one just because those numbers here, those coefficients, are a little bit smaller. So now I'd say 4 times x, we just figured out x was 70, plus 2y is going to equal 400. Okay, 4 times 70 is 280. So 280 plus 2y equals 400. Let's subtract 280 from both sides. So I'm going to be left with 2y equals 120. And divide both sides by 2, and y gives you 60. Okay, so let's answer the question at the end and say it's going to cost us $70 per hour of loading and unloading. It's going to cost us $60 per hour. Per hour of packing and unpacking. Okay. So guys, that's how it works. So the big thing here was to be able to take the information, okay, that we're given about our moving prices, and first create a system and take that system and solve it by elimination. So if you need to, I'll scroll down here a little bit more if you want to take another look at it, or pause this video. Okay, and please, if you do have any questions, make sure you're sending me a remind message or an email and asking me. All right, let's do another one. I'm gonna skip that. All right, so Ivan, you guys like the name of that? Must be from Apple. Ivan charges an hourly rate for a moving team to load and unload a truck. The charge is a different hourly rate for a team to pack and unpack boxes. Okay, so use the quotes to determine Ivan's hourly rates. All right, what I would like you guys to do is pause this video. Try this one on your own. See, can you set up the correct system? Can you solve that by elimination? Then once you finish, unpause and we'll go over it together. Go. All right, welcome back, everyone. Let's go ahead and do this. So again, we're going to have one equation that represents our cost when we move on a weekday, and another equation that represents our cost when we move on the weekend. Okay, so for a weekday, well, first of all, let's define our variables. So same thing as the last example. Okay, so I'm going to use x to represent loading and unloading, and y is going to represent packing and unpacking. All right, so let's go ahead and set up our equation. So for a weekday, we have 8 hours of loading and unloading, so I'm at 8x, plus 6y, because it's 6 hours of packing and unpacking, for a total cost of $890. For weekend, we have 5 hours of loading and unloading, plus 3 hours of packing and unpacking, for a total of $515. All right, so there's our system. Now we want to solve it by elimination. So I'm looking at this. I either need my x's to have opposite coefficients or my y's. So I guess I could do x's. I'd have to multiply these both up to 40. Or to get my y's to cancel out, all we have to do is multiply the bottom equation by -2. Because then my y term here will have a coefficient of -6. So I'll eliminate really nicely. So I'm going to go ahead and do that. So let's go ahead and multiply the bottom equation through by a -2. Both sides of my equation. Okay. What am I do? So then we're going to have the first equation still 8x plus 6y equals 890. My bottom equation now, when I multiply through by -2, I get -10x minus 6y equals 515 times -2, which is -1030. Okay, let's go ahead now and add the equations together. So 8x minus 10x is -2x. 6y minus 6y is 0. And then 890 minus 1030 gives me -140. We're going to divide both sides by -2, and x is 70. Okay, let's take what x equals now, plug it back into either original equation. I picked the bottom one. So I'm going to say 5 times x, so 5 times 70, plus 3y equals 515. 5 times 70 is 350. Okay, let's subtract 350 from both sides. I get 3y equals 165. Divide both sides by 3, and y is 55. Okay, so it's $70 to load and unload, $55 per hour to pack and unpack. Okay, so for now, guys, go ahead and try the lesson check for today. It's just one problem that's just like this. Okay, if you have any questions, please send me a message, ask on the discussion board, or shoot me an email. That's all for today, guys. Take care.